Hello, this is Mark Tucker for another episode of Jovo 4 Explained. In this lesson, Lesson 2, Quick Start and Debug. One of the things that I like most about Jovo is just how quickly it is to get started on a new application. Here on the Jovo website, we go to Docs Getting Started. The first thing that it tells you to do is that we need to install the Jovo CLI. Now this CLI has a number of different commands that are going to make this process easier for you. And I've already got that installed. After we do that, then we're going to create a new project by using using the Jovo CLI, the new command, and then what the name of the project is that we want to create. So let's go ahead and just jump right in to that. For the command line, I can type in Jovo -- version. This is going to tell you which version of the Jovo CLI that I have installed currently. And it looks like I'm ready for an update, but we'll do that a little later. It tells me what operating system I'm running, what version of Node, etc. So if I do Jovo new, let's go ahead and call this Jovo 4 Explained App 1. Then it's going to run us through this little tutorial where we can pick some of the different features. Here you can choose one or more platforms. In the previous video, we talked about platforms and what they are. In this case, I'm going to go ahead and select the Jovo Core platform. We could also select Alexa and some of these other ones. We're just going to pick the one for right now. It defaults with list of locales. We're just going to go ahead and use the default English locale here, and we're going to choose to use TypeScript. We're not going to save this preset that we just did in a config, and we'll just go along. So what that's going to do is go out and pull the template that we've got, bring it down here local, and now it's running npm to install the different packages. While it's doing that, let's go ahead and just take a quick look at what we're going to accomplish today. So already we've talked a little bit about the Jovo CLI. We've looked at the version. We've created a new project. When this finishes doing the Jovo new, then we're going to switch into the directory for the project and type in Jovo run. Then we're going to talk about the Jovo Debugger. It's a web client, and it has a capability of tunneling into your local host, because when you're running your Jovo project with Jovo run, it's just running your API, your webhook locally, and the Jovo Debugger connects through that through some sort of a tunnel. If you've used ngrok before, where you take your local host, code running on local host, and expose it to the internet with a public HTTPS endpoint, very similar, but there's some kind of cool things that happen with that. It's also important to note that behind the scenes, there are different cases where you might be entering text into the Jovo Debugger, and it needs to have some sort of an NLU to turn that text into an intent. Behind the scenes, by default, Jovo Debugger uses something called NLP.js and a local model file. Then we're going to look a little bit at the app code. Not really the project structure yet or any of the actual code for your handlers, but kind of the glue, how the server piece, how to get in there, the app config, kind of what's going on there. And we're going to talk a little bit about the basic logger. So that's what we're going to accomplish today. Let's see how far we've gotten. It's still doing some dependencies. Oh, building configuration. Oh, good. All right, so what it says here on our screen is that we need to change directory into the Jovo 4 Explained App 1 directory. And I'm going to go ahead and jump out of just Windows Terminal, and I'm going to jump into Visual Studio Code by going ahead and entering in that command, and then we're going to have to still run Jovo run when we want to actually execute this. So here is our project. Here's all the different files that come by default here, and we're going to go ahead and open up a terminal. Even though I'm running on Windows, I've got Visual Studio Code set up so that I have a bash terminal. You can see that there. And I'm just going to take a second and turn off debugging. So we're not going to step through code right now. So remember the command that we needed to run was Jovo run. So what this is going to do is start up a local server running on port 3000, and then we'll be able to use the Jovo debugger to get to here. And it says to open the Jovo debugger in your browser, you can press the period key once things are set up here. So it's turning on watch mode, which is handy. As you make code changes, it can restart. And then you can just keep using the Jovo debugger. And it just makes for a quick update cycle as you're running through things. All right, so it says that we are listening on port 3000, and it's giving us this webhook URL. So I can click on here and copy that. I can open that up in a browser, or like I said before, we can hit the period key, and it's going to open up the Jovo debugger. So I've already got a Jovo debugger opened up. It has a unique GUID specifically for me. And it's this location here. So without even really knowing much about how to use the Jovo debugger, it looks like we've got a place to enter in some text, probably like a chatbot would, some voice input, some global buttons, the sidebar here for lifecycle. So let's go ahead and launch this application. And what we see is that I've asked to launch the application, and the chatbot or the assistant, whatever it is that we're building, comes back with a do you like pizza? Yes or no. I can choose to answer by clicking on one of these global buttons, for example, and it says yes, I love pizza too. So let's take a look at this chat interface. One thing that we'll notice is that when we click on this, it changes color. This life cycle on the panel here reflects what that current conversation turn is. So the request came in for a launch request. The bot came back with "Do you like pizza?" with some buttons. That was one conversation turn. That's a request, a response, and then this yes intent is what I responded back with, and by clicking on this yes button. And then it came back. So let's take a quick look over in this life cycle. The first thing you'll notice is this request. The request coming in here is of a specific platform type called Jovo Debugger. So Jovo Debugger actually is its own platform, which really means is that there are some certain classes that interpret what the input looks like, the JSON input, and the JSON coming back out, the response has a certain format, but if we notice that here's the request ID, timestamp, here is the input. In this case, it was an input of type launch. We can see that there's a section that talks about device, and the device has a unique ID. A session, the session has a unique ID. There's a state stack that's empty. This flag that says this is a brand new session, and then here's a unique ID for a user. So the request comes in, some different things happen to it, and then in the end, the platform specific response comes back. So this is a Jovo Debugger platform output. Here's the message. Those buttons are called quick replies. It also includes a state stack. Now, if you think about as you're having a conversation, you might be at a certain part in a conversation, and the valid input, like in this case, the valid input is yes or no. Anything else, you might want to redirect them back to the question that you asked, which was, do you like pizza? So just think of the state stack as a kind of a placeholder of where you are. And a component, and when it comes to code, a component is something that you write. It equates to a class, and then in some cases you'll see a handler, and that equates to a function. So for example, just digging into this a little bit more, this request comes in. If you take a look at the input, this is just showing the same input that was part of this here, but just kind of split out separately. If you come down here to a router, it's saying that it figured out based on the intent that you had, or the command, which was a launch type, that it should call the global components launch handler. And this is the one that it resolved to, and in this case there's only one possible match, but if there were multiple matches, it would include those, and then it would pick the one that was the best. So then that gets routed, and as that handler is processed, then you can add output, and this is a you can kind of think of this as a platform agnostic or kind of generalized output, just like this is a generalized input. But then at some point, this output needs to be converted to the platform specific response. So if you notice, you would come back in here for this next request coming in. It's a little bit different. It's got a different request ID, but the device session and user ID is the same. You notice that it says that it's not a new session, and it has something in the state stack. And then the input type is an intent. So if you look at the input, it's an intent. When it comes down here to the router, then it says, oh, I've got some possibilities of what it could be, but I matched the love-hate component with the loves pizza handler function, and that's where the code's going to get routed to, and then any code that you put into that handler is going to be the thing that builds up the output, which in this case, is an answer. This listen false is in a voice app if it's going to turn the microphone back on. So this is kind of how you get your conversation back and forth. But we didn't turn it on, so actually that equates to the session is ending. In session is true, and that's the conversation. Now, if you notice, there are a couple of other ways that we could have answered this yes/no question. So like if we were to start over again, we could say yes, no. We could actually type in, yes into here. And if we look at this request, there's a third type of input, which is a text input. Now with a text input, you have to derive some meaning. So some additional NLU has to happen to turn that yes into an intent to know what to do with it. So if we come down here, we can see the input, that's the text yes, but there's another input down here which turned that into a yes intent. And we'll get to how does it know what intents there are for this application. There are no entities or slots to fill on this, and this is the native code. So something is doing the NLU for this, and it's looking at different things, and it's saying out of these possible intents, yes or no. Yes scored a 1, which is the highest, and that's why I selected the yes intent, which means that's why when it comes down here to the router, then I picked the yes, which is the loves pizza. So that's another way to get input, is by typing in text here. Let's do this one more time. The last option is that we can click one of these quick replies. And when we click one of the quick replies, then we can come back up here, and what that turns into is just a text input. So clicking a quick reply is the same thing as if you would have typed it in here and entered it. You can clear this, restart a new session. So that's just kind of an overview of the debugger and how it works. So let's quick check back here with what we're doing. Kind of, we talked about some of these things. So let's look at the code here. And The first thing I want to do is, where do things start? How do things get in here? The first place you want to look is actually this server.express. So this is an Express.js app. So there's a server listening on port 3000, and that's where we get this message that said, listening on port 3000. But it exposes a post webhook to then take the request, whatever JSON request is coming in, feed that into Jovo. It uses information with some configured platforms to determine if it's a platform it supports, and then lets that platform process the request. And we saw all the different steps in the Jovo Debugger. So next thing to look at is this app.ts and this app.dev.ts. So we're running in dev mode now, which means anything that's in app.ts is merged with anything that's in app.dev.ts to kind of form a complete picture of what we're dealing with. So in this case, we can see that when we used the template to create this, we said we wanted the core platform. So here's a core platform plugin with no additional configuration, which actually what that means right now is that there is no NLU configured for it. And we've got a logging flag turned on, which is going to turn on our basic logging. And if we look at the dev version, we were using a file database to store any user information, and it's actually storing it in this DB file here. And then it's configuring the Jovo Debugger. And even though we're not passing any arguments to the Jovo Debugger, it's using NLP.js under the hood to do that text to intent mapping. The next thing we want to take a look at is just really quickly this Jovo Debugger. Those global buttons that said launch, yes and no, this is where they come from. And so basically what we're saying is with a button with a launch label, when we click that, it's going to send the input as type launch. When we do yes, it's going to send the input as input intent, yes intent. You could change this so that it said that the input was actually text and then type in the words yes. Or you can actually even like take a whole JSON object and put it in here. We'll have a whole session talking just about the Jovo Debugger, but wanted to bring that to your attention. The other thing that we need to look up here is in this models section. This is a JSON format that's specific to Jovo, but it's a way to define. So in this case, we've defined two intents, a yes, no, and a no intent, and then the phrases or utterances that map to those. And that's how when we type in the word yes, that the NLP.js uses this model to determine what the possible intents are and figures out if it matches one of these phrases or how closely it matches one of these phrases, and it picks that intent. Let's see what else we've got in here. I think that's the main part that we want to look at. I do also just want to jump in here, even though we're not talking about this today, is these components. So you've got a global component. When the global component matches the word or launch, which is that special launch intent, it's going to actually redirect to this other component. When it redirects to this other component, it's going to, by default, call the start handler unless you specify something else. That's where you get your do you like pizza, and it's using a special output class. This output class is what's giving you the quick replies and that listen on it. But if you notice at this global level, nothing else is really happening. Launch is redirecting directly into a component, and that's why this love hates pizza component is on the state stack. Once you go into that, and then you can decorate these handler functions, love pizza with the yes intent, or hates pizza with the no intent, or if they get some sort of input that doesn't map to any of those things, something that's unhandled, all we're doing is redirecting them back to the start, which is going to ask the question over again. And so you kind of can contain the input of what you want at any particular point in time by using components. All right, so that's great. But what we haven't really talked about is how the Jovo debugger, how it maps to this localhost 3000 / webhook. So let's do this really quick. We're going to open up one of my favorite tools called Thunder Client. This is like POSTMAN if you've used it, but it's just integrated directly in. So let's go back out to our Jovo debugger. And we're going to do another, let's just do another launch here. I'm going to go ahead and take this, this request right here. Take the whole request. Come back here to Visual Studio Code. That's going to be our body. We're going to change this to a post request. And now where do we want to go? So we've already said that this is running on localhost 3000, and the server configuration said that the endpoint is going to be webhook. So if we do this, Jovo platform, Jovo debugger platform with the launch request, we go ahead and send that to the back end, and we get a response back like we would expect. A 200 OK. Here's a response. Do you like pizza? Now, this is kind of the cool thing that that you may not realize until you start using it, is that if we come in here, we've got this second launch request. Here, we'll even clear this out. So there is nothing in the Jovo debugger, but if I'm over here in running in my request client here, then I can go ahead and start this up. And when I come back here to the debugger, it shows me this same request being sent, but then I can also process it. So if I were to be creating something like an Alexa skill and I'm testing it, I'm running it local with my webhook, but I'm wanting to actually talk to my device, I can talk to my device and use it, but I can come back in the debugger and I can get like a transcript of what we were said, what we were talking about, what were the different intents or things that were hit, what information was saved. So that's pretty cool. So that is, it's able to do that because of this tunneling. So the localhost 3000 webhook is being tunneled with this exact same, this is like the public facing, and the localhost is the private, local only server endpoint. So what I should be able to do is I should be able to take this webhook URL, come back over here to my Thunder client, and just replace that. So now I'm using the public endpoint. I'm going to do a few other things here as I go through. I'm going to just kind of simplify this because it doesn't really matter what your strings are. So that's going to be request. Each new request is going to get a new request ID. So request 1, let's call this device 1. This is going to be session 1, and this is going to be user 1. All right, so Jovo debugger, and it's going to be a launch request. So let's go ahead and clear this out. Just so we can see that. Send. All right, good, that worked. We can come back here. We can see that the request coming in was request 1, device 1, session 1, user 1. Very cool. Now, if I wanted to continue this conversation over on this HTTP side, I have to remember that the act of doing this launch request added something to the state stack here. So let's go ahead and grab this state stack. and come back here to here. So like if I wanted to then update the state stack, I also need to make sure that I set this to false, or it's going to think I need to start the session all over again. Just for good practice, this is going to be the second request coming in, and instead of a launch type, we're going to go ahead and do this be a text type, which is going to require a text property with the word yes. So let's double check where we're at. So yes, we're at the point in time where we're answering yes or no. So let's go back here and execute this. And there we go. We got the response back. Yes, I love pizza too. We can see that it ended the session. So that's great. So let's go back here to launch. Now we've got this. When we created this, we have the core platform defined, but we haven't done anything with the core platform. Anytime that we use something inside of this this GUI here, then any of the requests are going to come in as the Jovo Debugger platform. But let's see if how we could go about testing something that was in the core platform. Maybe the functionality is the same, maybe the functionality is a little bit different based on which platform comes in. So we're going to go ahead and come back here, and instead of Jovo Debugger for our platform, we're going to go ahead and set core. We're going to go ahead and take off this right here. So we're going to start all the way over again. But this time it's with the core component. So if we were to send this, now we have a response that comes back, and it's core platform. Why are we able to do this? Because the Jovo Debugger platform is just based off of the core platform. And the only thing that really changes in that case is that it's got a different platform name. But if we were to go back here to check this out, then we can see that the request came from core platform, turned it into some kind of platform agnostic input, did the processing, did the routing, and then got the output and turned that output into a core platform specific response. And if you notice, because we had changed that we're going against the public endpoint. So we can either use the local host endpoint, we could use the public webhook endpoint, but we can just hit things here. Now this is the part that's going to show us that we don't have NLP or any other NLU defined for this, because we're going to go ahead and change this back to text. And we're going to say yes, and we're going to go ahead and grab this output from the previous request that we did with the state stack, add the state stack back in, new session is false, and when we send this, then we get the question, do you like pizza? So it handled it gracefully, but even though I send the text yes, I'm getting the question prompt again, because if we look at this, then it's showing that the text came in, correct, it's the core platform, the text, but when it came down here to time to try to route it, it didn't do there wasn't any additional NLU step to change that text into some sort of an intent. So the router had to decide what to do. And the router had this as an option, this unhandled handler, which, if we remember, went back and asked the question again. And so that's how it was able to handle that. So that's kind of what we've been able to cover here, just really quickly. Hopefully that demystifies some of the things. One of the things that we can also do, oh, here, this would be an interesting thing to do. So I wanted to take a look about like the app code here and kind of the console terminal. If we were to look down here in the terminal, you can see, formatted nicely is this request. It even gives you a timestamp of when the request happened, what type of the request was. So here's the whole request object, and this is the response object. That's because we had logging turned on and this basic built-in logger. So the whole process of getting the request in, converting it, running it through the pipeline, figuring out what the handler was, executing the code from the handler, building up the response took 62 milliseconds. So that just kind of gives you an idea. Also, this is helpful for debugging different issues. So we're going to come in here and we're going to play around a little bit. And we've got the Jovo Debugger platform defined and the core platform defined. I'm just going to come up with some fake platform. Now, it shouldn't be able to find it because we don't have anything that accepts a format of that looks into this request and it says, oh, if the platform equals fake, then do this. So what's going to happen is now we're going to get kind of this wheel turning. If we wait here long enough, then we'll get this error here that says matching platform, no registered platform can handle the request. And if we go back here to the debugger, maybe it didn't even get that far. That was core. Yeah, so it doesn't look like it even. Yeah, it didn't even make it far enough to get through this process because it couldn't identify what the platform was. So that's also a way where the terminal console here is going to help determine. So in this case, it timed out. It couldn't find one. So we got a 408. But yeah, so this terminal window with some of the console logging, nice color-coded in different cases, could help you kind of track down some of the bugs that you've got. So the last thing I wanted to talk about was in the previous video we talked about the RIDR lifecycle, which stood for request, interpretation, dialogue, and logic, and response. Here's the different middlewares that you can plug into. We showed with that console output that we just did with the kind of the fancy request and response, that's handled for us by turning on logging, which uses the basic logging behind the scenes. The different steps that we see in the Jovo Debugger on the right-hand side is like, oh, here's a request object. Here's the input NLU object, the route object, the output, and the response. Notice how those correspond with different points, different middlewares, and different steps in the life cycle. And for this project that we had a Jovo Debugger that has automatically configured for NLP.js. We did a core platform. We didn't define any NLU, and that's why we got the unhandled. There's a built-in router plugin and handler plugin and output plugin that helps with these different steps, turning the platform-specific request into generic input, handling that, building generic output, and turning that into platform-specific response. The last part, and I'll just bring this up really quickly, is that you can use the user ID as a key, and if you have a database plugin defined, then you can even test out storing things across user sessions. And the way that this is, what a typical starter project uses is the file DB, and that will be the last thing that I will show you in here. If we come in here to the database, this is probably going to have a number of different turns in here, but it's basically just a file that includes an object for each of the different user IDs. So here's that U1 user ID. We didn't store any user data, so it's an empty object. But that's how database integrations happen. So thank you very much for joining this video. We covered quite a bit. but I just really love how Jovo allows you to just get started really quickly with the template using the Jovo CLI, then jumping right in and debugging and being able to understand how the debugger works. And you can use the debugger and the debugger UI, or you can connect just through HTTP request response with different platforms, and that your interaction will record what's happening into the Jovo debugger. Thank you for watching this video series. In a future version, we're going to cover some more. We'll jump into the actual project structure, what that means, how to modify different things, how to debug through, just lots of different things. So stay tuned. Thank you very much.